Here is the continuous compounding interest formula. We have A equals to P times E raised to the R times T. A is the accumulated amount after T years. I simply call that the final amount. And P is the principal deposit. I simply call that the initial amount. R is the interest rate, and then T is the time in year. This continuous compounding interest formula is based on the formula written on the right. So this formula, the one written on the right, I discussed that in the previous video. So this is a compound interest formula, right? So the difference between the one on the left and right is I use an M. Do you see that? So they both have A, P, R, and T. The only difference is the continuous, the one on the left has a base E, and then the one on the right hand side, I use M. What is M stands for? M is the number of compounding in a year. So let's say M is equals to 4. That means I'm going to calculate the interest every quarter because there are 4 quarters in a year. If M is equals to 12, that means I will calculate the interest every month because there are 12 months in a year. If M is equals to 52, that means I will be calculating the interest every week because there are 52 weeks in 1 year. And then I also did an example in the previous video. So let's say I calculate the interest daily. So that is M equals to 365. And then all you have to do is you plug in the P, and then the interest rate, and then the M, and then the time in year to the compound interest formula, and then you are going to get an amount. So that is A. A is the final amount, and then the interest you earn is you take the final minus the initial. But what if I want to do more than that? I want to do more than 365. So how about this? For 365, here is the concept. So let's say on day 0, you put $1,000 to your bank account, day 0. And then on day 1, I will calculate your interest. So at the end of day 1, what you are going to get is your principal plus the deposit you earn on day 1. So at the end of day 1, you have a little bit more than $1,000, right? And then at the beginning of day 2, I will calculate the interest based on that amount, which is your principal plus the interest you earn on day 1. I am going to calculate your interest based on this. So that means the interest you are going to earn at the end of day 2 is a little bit more than day 1, because when it comes to day 2, you have a bigger principal amount, right? Because you have your principal plus a little bit of interest you earn on day 1. And then for this interest, like calculating interest stuff, I am going to do this every day for the entire year. So that's why if you choose to calculate, if you choose to compound the interest like daily, the final amount that you are going to get is a little bit more than weekly, because 365 is greater than 52. I'm going to do this every day for the entire year. That is certainly greater than I will do that every week in the whole year. Now, how about continuous compounding? Continuous compounding means I want the M to be greater than 365. That means I want to do more than that. So you can think about this. I will be calculating the interest every second, or every little half of a second, or every little quarter of a second. Or you can think about this, when M approaches to infinity, I want to let the M be infinity. So that means I am going to do this many times, continuously, non-stop, every little minute, every little moment. Okay, so what you are going to get is the 1 plus R divided by M raised to the M power. This is the limit of E. Do you see that? The formula on the right, there is a one. There are some part of the formula is in blue, and that is the limit of E. E raised to the R power, which is the limit as M approaches to infinity, 1 plus R divided by M raised to the M power. So as long as M goes to infinity, the entire blue piece is just a base E. Okay, so that's why it's just base E raised to the R. So that's how we get E base raised to the R, and then times T for continuous compounding. So I have a little example for you. So take a look at this. So we have the future amount equals to unknown, and then the principal amount is 2,500, and then the interest rate is 4%, and then 10 years. So what is my final amount going to be? So let's calculate this. So A is equals to the principal, and then times E. raised to the R and then times 10, right? So this one, you plug in everything to your calculator. This is approximately equals to, for money, I will just use 2 decimal places, 3729.56. So that is your final amount. And then how much interest did you earn? So your interest is final minus initial, 3729.56, and then minus your 2500. So whatever that equals to, that is the total amount of interest you earn. But let me tell you this, when you do your homework, quizzes, and exam, the problem won't be this easy, all right? Somehow you have to do something difficult. Okay, let me give you the first example. So for continuous compounding, so here is the first example. So let's say I have $2,000 right now. Okay, and I would like to get $7,000. That is my goal. Deposit 2,000 and I want to get 7,000 for the total. And then I am going to spend 5 years. And then can you tell me the interest rate? All right, so let's do the plug-in. So A is equals to 7,000 and then equals to the principal, 2,000, and then E raised to the RT, right? So we don't know R, and then R is just a R, and then T is equals to 5. So first of all, let's divide 2,000 on both sides, and then you have a 7 divided by 2, and then this is E to the 5R. So now, you have to recall your exponential function. How do you bring the law of ln? How do you bring the 5R down? The answer is you have to take ln on both sides to carry the exponent down. So now ln on both sides, one thing that I would like you to do is do not approximate the 7 over 2. Do not approximate the ln 7 over 2. I want to get an exact value. So this is a 5R and then times lne, and then lne that is equals to 1, right? So lne is equals to 1. So R is equals to the ln divided by 5. 7 over 2 divided by 5. So this is an exact answer, right? So when you do this on your calculator, make sure you type ln 7 divided by 2, close the parenthesis, okay? Once again, 7 divided by 2, close the parenthesis. That means that you ln the 7 over 2 first, and then you divide it by 5. So this one approximate that to 4 decimal places. That is 0.2506. So what's the percentage? The percentage is 25.06%. You have to multiply 100 and then add the percentage symbol. All right, so let's do one more. The next one is, how about this? Next one, let's switch to a different color. How about I have $6,000 right now. I want to get $9,000. Okay, and then the interest rate, this time I give you the interest rate, is 8.5%. And then how long do I need to get my $9,000? So 8.5% is 0.085. And then you have to plug in. So this is a 9,000 equals to 6,000, and then E to the RT, right? So R is 0.085, and then T is don't know. And then you have 9,000 divided by 6,000. So that is 9 divided by 6. If you don't want to reduce the fraction, just leave it in there. E to the 0.085 T, and then you ln both sides to carry the exponent down. So now you have ln 9 over 6, that is equals to 0.085 t, and then times lne. So lne is equals to 1. We can just ignore that. T is equals to ln 9 over 6, and then divided by the interest rate. So this one I have approximately equals to, so here is everything I got on my calculator, 4.7701777742. And then how many years is that? For the years, I will just use 1 decimal places. So how about 4.8 years? All right, so that is the second example. So let's do one more. Let's do one more. Let's do something easy. How about this? I know that I am going to get 5,000, but I don't know how much I need to deposit right now. And then the interest rate is 6.2%, and then I am going to spend 10 years. How much money do I need to put in the bank right now? So the 6.2%, that is 0.062. All right. And then, oh, how do you get from the percent to the decimal? All you have to do is you divide it by 100, right? And then you have a 5,000, right? Don't know P, and then e to the 0.062, and then times 10. So this P is equals to 500 divided by the E, right? E 0.062 times 10. So this one I have, that is approximately equals to, let's keep two decimal places, $26.89.72. That is the amount that I have to put into the bank right now in order to get $5,000 in 10 years. Okay, so that is the end of this video. Do you like it? Is this helpful? If so, give me a like, subscribe, and share the video on any social media for me. I will catch you all in the next one. Signing off.